everyone, and welcome to this keynote. We hope this presentation finds you well in these difficult times. My name is James Belsey. I work for Morgan Stanley. I've worked for Morgan Stanley for just a bit longer than 20 years. And in the last 10 years, I've been involved in a project which is very dependent on Scala. And we've worked with a number of groups in the Scala community to help with the Scala platform and to have the Scala platform help us. Today, we're definitely going to show you some more of the technical platform that we've built, but we're also going to talk about some of the other things that we've been working on here in the last 10 years that are equally close to our heart. And we hope that you will find this interesting and motivational, because we also want to talk a bit about the fact that we are all very privileged because of the opportunities that our careers have afforded us. And we expect that quite a lot of people in the audience will also be in that position. And we want to talk about what you can do with that privilege to help other people. And we hope that you find that interesting and fascinating as we have in the last 10 years, as well as we hope that you're going to also find our technical aspects interesting. And we hope that in the next few years, we'll be able to work with more people to expand the scope of the technical project that we're working on. I'm going to start with a little show reel of some of our previous talks. In our previous talks, we talked about the platform that we have at Morgan Stanley based on Scala. It's many millions of lines of code. We keep a lot of data, multiple terabytes of data, and we have hundreds of programmers serving thousands of users, all working on the platform, which is completely Scala based. And we have worked on that quite a bit, and we've shown quite a few presentations. I'm just going to show some highlights of those presentations now, hopefully to inspire you to watch some of them. These are our millions of helpers. We also talked about multi-threaded and how it's hard and what we do about that. We show a lot of code in our talks. We talked about object ownership, simple object ownership, and really complicated object ownership. And we talk about how we solve that ownership problem. We also have some humorous graphics to depict how hard it is to solve that problem. And like I said, we show a lot of code. Here we're talking about our data layer with multiple terabytes of data in, and how that solves the nightmare for people, using a sort of clever way of dealing with monadic constructs. And in all of our talks, we've had reference to our referential transparency superhero, as referential transparency is the thing that our platform is built on. It's the functional programming construct which has revolutionized our platform, and we're very grateful to Scala for enabling the facilitation of that platform. And today we are going to cover like another technical aspect that we have, which we think will be really interesting for everyone. It's certainly been fascinating for us to work with that over the last decade, and it's brought us lots of innovation, and we hope that it potentially does the same for other people outside of our company. And whilst we are definitely going to do that, and I absolutely promise we'll show a technical presentation, we're going to start by talking about something else. But it is something that is equally important to us, and we hope that it will be interesting to you, and it will be motivational to people to do similar things. So in order to talk about this, I'm going to talk a little bit about Morgan Stanley, which is where we work. Morgan Stanley is a large multinational company, and when you have like such a large group of individuals, it's helpful to have a guiding set of principles that we operate on. This is the entrance to our office in London, and as you can see, the principles are written on the wall. They are self-explanatory, and they help us with daily decision making. So doing the right thing, putting clients first, leading with exceptional ideas, committing to diversity and inclusion, and giving back are things that it's very easy for us all as employees in Morgan Stanley to internalize and live by those values, and to make sure that we embody those values when we're working. And today I want to talk particularly about the value of giving back. And what we're going to do is we're going to start with Daniela, and she is going to talk about a schools program that we've been running for approximately 10 years at Morgan Stanley.
Thanks, James. My name is Daniela. I'm a senior engineer at Morgan Stanley, and I'm going to talk to you about our school program. Our school program is called Impact, and hopefully I'm going to convince you that that is a really good name for it. IMPACT stands for Improving Aspiration in Computing and Technology. And it was a program that started following the hard work of Simon Peter-Jones and the Computing at School Society. So Simon Peter-Jones is known in the Scala community as the main maintainer and contributor of the Haskell language. But in the UK, he's also well known for his hard work in reshaping the UK curriculum in schools. So it didn't take one day. It took him and the Computing at Schools Association roughly 6 years. It wasn't easy. But eventually in 2014, computing was part of the curriculum in the UK schools. And since then, roughly 2013, Morgan Stanley has been active with this program that consists in donating volunteers' hours to teachers that are teaching computing to students and are willing to assist them in several ways, helping with labs, helping with reviewing exams, etc. And this program, in almost the 10 years that it's been running, has grown a lot. So we have mainly focused on the London area. We currently have partnership with roughly 15 schools, and we have 200 volunteers. And in 2019, we have volunteered a total of 13,000 hours of teaching in school, which is amazing. Of course, COVID in 2020 made things a little bit difficult. So in 2020, we have done roughly half of those amount of hours. But even today, we are still volunteering with online sessions with our students. And we've even have started bringing this collaboration in the New York area as well. But and this, of course, has an impact on the students in the UK. Students have a national exam so that the scores can be compared between different schools. And what we have seen is that students that we mentor tend to have better scores than the national average, which is great, right? We are making an impact. We are dedicating resources to mentor students specifically, which improves their scores. But you might ask why a beer corporation is interested in improving the scores of students in the local community, specifically in computing. And that brings me to why the impact name is such a great name. And this program does really make an impact, first of all, to the students. So the students that are really passionate about computer scientists have an opportunity to build a relationship with our volunteers, and they have the opportunity to ask questions about the career path that they could take as a computer scientist. Maybe they don't know any other computer scientists and not sure what they should study in order to pursue that career. Maybe they have no idea what a computer scientist does all day at work. They think that all we do all day is maybe converting binary numbers. So we have a unique opportunity to speak with the students and to tell them more about what is the career path that we have picked and what is the tasks that we usually do at work. But also this is important not just for the students that are passionate about computer science, but also those that are not really into computer science. And the reason why this is important is because we all have cultural preconceptions. This is true for all fields, not just for tech. And the idea is that if you were to ask me, what does a scientist look like when I was probably in my teen years, I would have told you that a scientist is an old guy with a white coat. And if you were to ask me when I was 15, well, what does a computer scientist look like, I would probably tell you that it's somebody that really likes video games. But of course, we know that that is not what a computer scientist look like, or necessarily what he enjoys. So it's important to show our students that we are all diverse, and computer scientists don't necessarily look like what the cultural bias would expect us to. But also gives them a really important message. That is, if you want to become a computer scientist, if computer science is what you're interested in, it doesn't matter what kind of family you come from. It doesn't matter what kind of background you have. If you put the hard work in and you study the right topics and you have the right types of work preparation, yes, you can become a computer scientist. So this is extremely important for us to bring diversity into the tech community. But also, you know, this is really good for Morgan Stanley. Morgan Stanley is promoting its name in the local community. So we hope that people would associate the Morgan Stanley name with all the volunteering that we do. And of course, we are building relationship with students that one day might apply for an internship at Morgan Stanley. So it's a really powerful long-term recruitment tool. But let's not forget about us as employees. And you will be surprised how people find motivations in volunteering. Everybody's different. That is one of the key messages that we want to show our students. So the reason why I like to volunteer, and for me volunteering is really important, is for two main reasons. The first one is that it's really important. It gives me an excuse to walk away from my desk, walk away from my regular work and do something completely different that I absolutely love for 2 hours. And everybody knows that on Friday morning, those 2 hours, I'm not going to be around, and I can just spend my time talking with students. And that reminds me of when I was younger, and it really brings joy to me being able to help them and advise them if computer science is the field that they want to have a career in. But also the second reason why I really love to volunteer is because sometimes things don't work. Sometimes you have a bug that is really, really difficult for you to solve. And then after you explain how to convert a binary number to students, you realize how far you have become. And that really gives you the motivation of, yes, I was struggling with this stuff once as well. So that really gives me an opportunity and the strength to go back to my bug and actually fix it. But again, we are all diverse, we are all different. So let's just not take my word for it. So we are now going to hear from other volunteers. Specifically, we are going to hear from Damask and from Gjeta. And Gjeta, she is also going to talk about another educational program that we run at Morgan Stanley and we're really passionate about.
My name's Damask Brown and I'm a C++ developer. I've been volunteering with Impact for 5 years now. Back when I first started volunteering, I was an intern. It was my first 6 months at the company. I was in the middle of my degree, and at work it felt like I was surrounded by experts in everything. So in a lot of ways, volunteering back then was a comfort. It was a change of pace from that early and really, really steep bit of the learning curve. For a few hours a week, I could be an expert in something. Python, data protection law, IEEE 754, everything in between. It's a really, really broad curriculum. More importantly, though, I got to teach people how I approach problems that I don't know how to solve myself yet. It made a massive difference to my confidence as a person. Gradually, I just wasn't shy anymore. It made me a better communicator at work because I was so used to coming up with teaching abstractions on the fly. And my experience isn't unique at all in that respect. I now get to watch this happen to people all of the time, every year. It's one of the most rewarding things. 5 years on, I now do get to call myself an expert in some things, but I'll keep volunteering because it gives me breathing room. In the weeks where things are frustrating or slow moving or a combination thereof, I get to know that I've still done something useful and valuable and that I've helped someone, and they might remember that. I get to leave my own work problems running on a background thread in my brain and just do something else. And often that makes all the difference.
Thanks, Damask. My name's Gjeta, and I'm a software developer on the platform team here at Morgan Stanley. I have worked on the team for about 5 years now, and pretty much since day one, I've been involved in volunteering to teach GCSE computer science at local schools through Impact. For me, as Daniela mentioned, the big appeal at the beginning in particular was that I went from feeling like I knew nothing at all about this huge system that comprised of millions of lines of code, to feeling like I really did know what I was talking about and that I had some value to give to these students. But for me, the most rewarding aspect of the volunteering that I've done over the last few years has been not only teaching the GCSE content to the students that we teach, but being able to talk to them about things like university and university fees and their options, or apprenticeships, or the applications of computer science, and the fact that there are careers outside of medicine and law for students who are passionate about problem solving and numbers and science. Throughout the years, I've met a lot of inspiring students, a lot of really bright kids who clearly have potential and who maybe don't have opportunity. And I think what our impact program has really shown is that although talent is spread evenly, opportunity is not. And that's something that I've really seen firsthand. These students are as talented as those that you would find in maybe any private school in the UK, but the opportunities that they have access to are so much more limited. So given that they are literally on our doorstep in Canary Wharf, Global Code is a charity that started in 2017, and James is a trustee of that charity. And James gave the opportunity to Morgan Stanley volunteers who had been most involved in the local volunteering program to travel to Ghana to teach university students computer science. So in July 2018, 7 Morgan Stanley volunteers traveled to Ghana, and we were scattered across the University of Ghana, Koforidua Technical University, and the University of Cape Coast. In total, we taught 75 students in their 2nd or 3rd year of computer science or related degrees. Most of them hadn't written a line of code before, and their lectures consisted of memorizing facts, and there was very little in the way of coding or software development. Global Code gave them the opportunity to learn Python using Raspberry Pis, and in the week that I spent there, I spent most of my time in the classroom, jumping from team to team at the University of Cape Coast, helping them to fix bugs or to set up their various projects. And they worked on a huge variety of different projects. One team had a kind of doorbell turned security camera project that would take a photo of whoever was at the door when you pressed a button on the Raspberry Pi, and then it would send a tweet to alert someone. Another team worked on a Tetris game that was controlled using an accelerometer. And another team came up with a temperature and humidity sensor for farming. But by the end of their total of 3 weeks, these teams were presenting their projects to their class and to members of the faculty. And one of them told me that they'd learned more in those 3 weeks than they had in 3 years of university. The students were, without exception, passionate and engaged and welcoming, and beyond everything, supremely grateful. And it was a gratifying experience to spend a week feeling that every second that I spent with a student was valuable, and every bug I fixed or every line of code I refactored or every piece of advice I gave was really making a difference. But my students taught me a few things too, particularly about perspective and what really matters. They would say grace before each meal, and they would end the graduation ceremony with a prayer. And when I reminded one of them that I owed him some money for lunch, it was about £1.50, he replied that I owed him nothing because I was already giving him so much. After the success of the program in 2018, we again had the opportunity to travel to Ghana in 2019. And by this point, the program had expanded, this time to 5 universities, the 3 that we'd been at in the previous year, but also Ho Technical University and the Kwame Nkrumah University of Science and Technology, way up north in Kumasi. In 2019, 18 volunteers from Morgan Stanley volunteered to teach on the program across the 3 weeks of the summer school. And in total, we taught over 120 students. For the first time for Global Code, half of those students were women. And a huge number, I forget how many of our volunteers were also women. So again, we taught these students, a large part of what our teaching was showing them that we don't always know the answers. The skill that we really showed them was how to really persist with a bug or teaching yourself something, you know, how to look for something on Stack Overflow, or how to read documentation, or how to just write things and break them and then rewrite them so that they work. And the really rewarding thing in the second year that I taught in Ghana was that this time I had a teaching assistant of my own, and she was one of the students that I'd taught at Cape Coast the previous year. Global Code is based on this premise that, you know, eventually Western volunteers won't be needed because all of the students that have come through the program will be able to come back as volunteers, and it will be run by Ghanaians and by locals. Partly because of the good work that Morgan Stanley volunteers did in Ghana, Turntable was set up as a sustainable social enterprise. The idea behind Turntable was to hire students that were coming through Global Code as consultants, and then to give those consultants opportunities to work in big companies such as Morgan Stanley. So because of our volunteering through Global Code in 2018 and 2019, we had access to all of this great talent in Ghana. And what we saw, just like we see through our weekly volunteering in the local schools, was that talent is evenly distributed. There were some extremely bright programmers in our classrooms. All that was lacking was the opportunity, and this is what Global Code and Turntable give them. And there are already 4 Turntable consultants now working on my team. And one of them, Deborah, is going to speak to you about his experience so far at Morgan Stanley.
Hello everyone, this is Simano Kofi Deborah, a software engineer at Turntable. I joined Turntable in January as a junior software engineer. When you join Turntable as a new software engineer, you go through what we call a training program, we call it TLC. TLC gives you in-depth knowledge in the software engineering, that is programming languages, Java, Scala, Python, and other software engineering skills like DevOps, and also agile development to prepare you for the real tasks ahead. I joined Morgan Stanley to assist, help, and maintain the Morgan Stanley build to help in code compilation being faster, and also assist developers in pull requests.
Thank you, Deborah. Hello, I am Harrison from the Graph team. I work with Deborah on the core execution platform.
And hi, everyone. I'm Valerie. I work on the SDLC team. So we're responsible for the developer workflow and the pull request workflow. So today we're going to talk to you about some of the core execution of our application. So for context, we have about 500 developers and around 7 million lines of code. So with such a large code base, we want a performance system which separates execution concerns from business code so that the majority of those developers can focus just on their applications. So what we're going to do today is go through an example using a flight pricing algorithm and talk about some of the underlying execution.
All right, so I'd just like to show you the algorithm that we're going to be discussing. Let me share my screen. So this is a simple model of an airline pricing system. Fuel is priced in a local currency, which has a exchange rate against the dollar. The cost of a flight depends on the distance and the amount of fuel it will use. And then each customer gets a discount based on their rewards points or similar factor. And the price of the flight depends on all of this calculation. So the model for this application is in code, and I will pull the code for that up right now. Valerie, would you like to explain some?
Yes. So the solution we have here, for context, it's motivated by some other related work in the Scala community. So what we've done is we're using Scala, but we've added some features to it that our developers are using. So the first thing I want you to focus on, you can see we have some classes. That the core model pieces are marked entity. I'm not going to go over that now, but if you're curious for a more in-depth explanation, we have some previous talks from our colleagues you can check out. So what we really want to focus in on is this idea of a node. So you can see we have classes and some of the methods and fields have @node on them. This is kind of a special contract we're applying to some methods, and it's saying that it is a referentially transparent function. So for those who are not familiar, that means it depends only on its input and its context, and it is its components are immutable. So when something's referentially transparent, you always get the same output for the same input, and you get some benefits from that above regular code. So in this case, it's memoizable, it's order independent. We also restrict side effects to only certain ones. So you're allowed to log, but you can't do a lot of mutating operations. So now we see we have several different classes. They're reflecting what's shown in the diagram. And then Harrison's going to piece them all together for us.
So the algorithm is written with plain Scala defs that are annotated with @node annotation, and it simply models exactly what is on the diagram. The cost of flight depends on the customer's discount factor, and the flight cost, which depends on the fuel cost, and the customer discount, which depends on the currency exchange rate, the amount of fuel that's used, and the local price for the fuel in the local currency. And if you notice that the method calls between nodes are absolutely standard Scala method calls. But part of what you get by annotating a method as a node is that it becomes a literal node in a dependency graph, such as the one shown on the right-hand side of the screen. And the dependency graph is materialized implicitly by the platform, and it tracks the dependencies between nodes. And this allows us to do many powerful things with the graph above and beyond what Scala does natively. So I'd like to show some of the power of this platform.
Okay, so now we're going to look at an application here. So you can note the enters graph annotation. What this means is that we are going to execute code in a controlled referentially transparent environment within that graph. And we've got some example objects here. So we can just run that really quickly. and we should get our initial price. All right, so around $94. All right, so this works well for the simple scenario, but let's say if you're writing this application, maybe you want to also do some calculations for what would happen if there were different exchange rates. Now, normally, if we wanted to vary that exchange rate in an immutable way, we'd have to copy these objects. And since the exchange rate is buried pretty far in this structure, we'd have to copy a lot of pieces. But what this framework is doing is we're allowed to say within a controlled scope, we're going to modify one of the nodes of our graph, in this case, the foreign exchange rate. So within the given block, that means we're entering the controlled scope. And instead of copying, we just add the new node, and the runtime manages this on the fly. Since the graph already exists, we're just adding it. And we're maintaining referential transparency. So when we see the result here, we're going to get both of our prices, and those are coming from the related calculations. So in our next example, we're going to add a new object. So let's say we have another customer. And again, we're going to get the benefit of the previous work we've done because we still have the rest of the graph. If you call back to the way our objects interrelate, the customer has an effect on the overall flight price, but it has no effect on the fuel price. So the subsection of our graph that has the fuel price, we're just reusing that calculation since it's been done earlier on. And we're recomputing only the customer related pieces. So we can see we have yet another price here. And Harrison's gonna walk us through another application of this framework.
So another application of this dependency tracking graph, which is built up by Optimus during the execution of an application, is the ability to make simple and reactive user interfaces with a minimum of effort. So I'd like to show how we can build a quick UI application of the sort that is used by hundreds of people a day at Morgan Stanley for several applications. So we can build a UI application with just a couple of lines of code here. So I want to start by making a basic window and move inside of it. And now we're going to use two text boxes here. So one will represent the exchange rate of the fuel. And I'm going to bind that to the same node that we were tweaking earlier, flight fuel local currency rate. And then I'll have a second one for the price. And this I will bind to the result of pricing the flight. And this will show up, and I will play this real fast for you. When you run this, these two text boxes will be attached to these nodes inside the dependency tracking graph. And updating the rate will update the price in the same way that tweaking the rate in the previous application changed the price when we next calculated it. So here is our application. And as you can see, it has the two boxes we asked for. And right now it's using the default rate of 1.3. If I change it to 1.5, then we calculate the new price and we immediately update the price box. So I can change it again to something else and another calculation, and the price immediately updates.
All right, so let's step back and apply what we've shown you more broadly. So we have this execution graph at runtime, very helpful for our application. And keep in mind that on our project, we have hundreds of developers, about 7 million lines of code. So obviously the systems are a lot more complicated than this, and the UIs as well. However, what we do require of our developers is that they write their code in a referentially transparent way. And this helps them write more in appropriate Scala paradigms. And also it lets us as platform developers fit the systems together in a nicer way. So for example, we have shared calculation grids that since many applications are reusing the same nodes, we can reuse those same subcalculations across the different applications. We have a consistent database system as well that also is tied to this. And so we've abstracted away a lot of the concerns that a developer more focused on business applications might not spend as much time thinking about. And there's some further applications for this concept. So this same graph we can also apply to compilation. So each node of the graph could also be thought of as an individual jar. And our colleague Andrew is going to speak more about that next.
Hi, my name's Andrew Brett, and for the last 3 years, I've been working on the platform team at Morgan Stanley, specifically focused around our build tool. Now, the build tool was a project we started to answer an important question, and that is, how do you have 500 developers working on a single code base of 7 million lines of Scala code and 6 million lines of Java code, and still provide them with a pleasant developer experience? And what I mean by that really is, how do you ensure that their edit, compile, test cycle is as short as it can possibly be? And when trying to answer this question, we looked at a variety of different build tools that are available, both in the open source community and commercially. But we found that in general, they had one of two issues. Firstly, if you compile that many lines of code from scratch, even if you do it in parallel where possible, you're looking at 30, 40 minutes, maybe even an hour or more to actually get that compiled on a standard developer desktop. Also, even once you've got the code base compiled from scratch, then if a small change can't be compiled in a few seconds, you've got an issue with developers context switching away, which means they lose that flow that's so important for developers' productivity. So what we were really targeting was a situation where a developer could start from scratch on whether it's a brand new machine or just a new workspace on an existing machine, and get up to speed, which is to say compile everything with no jars previously stored locally, within ideally 2 to 3 minutes. And then when they're making small changes to the code, be able to make those changes and compile to check the changes work in as little as a few seconds. As I say, we evaluated a lot of tools externally, and then we came to a realization. And that realization was that a build graph where you've got a lot of modules with interdependencies is an awful lot like the dependency graph that we'd already built for financial calculations. What that means is, if we model each module in IntelliJ speak as a single node in a calculation graph, then what we can ensure is that both we don't rebuild modules unless we absolutely need to, and the asynchronous nature of our platform means that we automatically get the parallelism that we'd be looking for, which is to say that if you've got 3 modules where 2 of them depend on a single common base module, then as soon as you've built that base module, you can start building the 2 downstreams in parallel. Furthermore, we worked closely with Lightbend to ensure that you don't even need to completely finish building the first module before you can start the 2 downstreams. You only need to get a certain amount of the way through the Scala compilation, which is to say really not much beyond the typer phase. And then as long as you output the signatures, it's really in general only the signatures that downstream modules depend on. And that enables you to start those downstream compilations as fast as possible and then shorten your critical path. In addition to that, we're aware that we didn't want a developer to have to build everything from scratch the first time around. So as well as the caching that's built into the platform for free that we made use of, we used both on-disk caching and also a remote distributed cache to ensure that if anyone's built those artifacts anywhere else in the firm, that you can make use of those same jars, just download them over the network, and rather than having to compile them, they're then available for you to use. That meant building or making use of an existing open source project that we have from Morgan Stanley called Silver King for our distributed key value store caching layer, and also ensuring that we had those distributed nodes as close to developers as possible. So we actually run a distributed cache globally with nodes in all of our major development centers to ensure that we can really make use of the network bandwidth that developers have on their desktops. With that being said, now let's look at some code and see how that actually impacts us in the real world. So here's the example that you hopefully saw earlier in the keynote. Again, I've got the airline pricing application with just one small change to it. Here I've added the concept of some global discount that we can apply to flight pricing, such that we can give a discount on top of any customer discount we offer to all of our customers. So if I go ahead and build this, and again here I'm building the entire project. I'm not just telling IntelliJ to build this single source file. I'm telling IntelliJ to build the whole project, and then IntelliJ will go off and ask our build tool to actually carry out that work using an open source library called BSP, which is already built into IntelliJ for communication with external build tools. So let me go ahead. I've built that now. I had admittedly previously built this code before the demo started. So you can see that what the build tool did was detect that no directories had changed. So it scanned the entire workspace that I have locally, which consists of 5,479 directories and over 150,000 source files, worked out that none of the source directories had changed, and it did that all in under a second. It then actually started the real build. So we had over 1,300 of what we call scopes built, and scopes correspond more or less one-to-one with an IntelliJ module. Note that we don't, at this point, pre-filter the number of scopes that we try to build based on the files that we know have changed. Scanning the file system is only used to inform the dependency graph of which source folders need invalidating, such that the dependency tracking will automatically ensure that when we try and build everything, only the things that have really changed will actually get built. So as I say, yes, we built over 1,300 different scopes, and in total, we did that in about 3.5 seconds. So that's all very well, but it turns out that you don't make a very productive developer just by allowing them to compile code quickly if the code hasn't changed. Real developers obviously need to go ahead and change their code. So let's go ahead and add a global discount in. Let's give all of our customers, we're feeling generous today, so we'll give them a 5% discount on their next flights. And again, I'll go ahead and I'll build every single source file in the project. This time, as you'd expect, the build tool detected that a directory had changed. And again, it did that in under a second. It once again built the same 1,300 or so scopes. This time, we got a real Scala compilation. We make use of Zinc to ensure that we can also incrementally compile both Java and Scala within a single module. So we asked Zinc to build this scope for us. Zinc detected that one Scala file had changed since the last time it was built. And obviously in that case, this is this dependency demo.scala, which we're looking at now. And again, even with that kind of building all of the code in the code tree, it took about 6.5 seconds, given that a single file had changed. Now, this is all very well, but again, we're not really looking at anything very representative here because we've got a single source file containing all of the code we care about with no downstream dependencies. So let's split this up a bit to try and simulate a real system in a bit more detail. So what I'm going to do is I'm going to take these different classes, I'm going to split them out into their own source files, and those source files I'm going to keep in different modules, again to try and simulate the structure of a larger application. So I'll take the customer out and I'll stick that in as its own source file within a customer module. And I'll do similar things for the other classes in here. And you'll note as I'm doing this, each one is in its own module. So fuel price is in a fuel module. Take out my global discount. Right. airfare price. Now I pre-set up these modules such that ScalaCon depends on them. So IntelliJ automatically knows that the FX rate is in a different module, and I can obviously navigate to that, and it will navigate to the right place. It's worth also briefly noting that as well as IntelliJ calling out to OBT to actually go ahead and do the builds, OBT being our build tool, in addition, IntelliJ talks to the build tool whenever it needs to find out about the project structure. So the build tool tells IntelliJ when that project structure has changed, and IntelliJ can automatically update its module structure and its dependencies so that you get all the nice IntelliJ features like code navigation and syntax highlighting and so on and so forth. So I've moved some of that code around, and now I'm going to build again. You can see this time that it detected 6 directories had changed. And as a result, there are a few different modules that needed to get built. These obviously correspond to the modules that I just put the new Scala classes in. In most cases, just a single Scala file needed building, but obviously Flight is the one where I put 2 source files, so there were 2 Scala invalidations there. Again, with those changes and a warmed up OBT server, that took a little bit under 7 seconds. Now let me go ahead and make another source change. So 5% was all very well, but maybe we need to reduce that a little bit. Maybe we'll just change that down to 3%, and we'll go and build everything again. Here you can see, again, it detected that there were changes. It recompiled the Flight module and invalidated this single file. Note, it didn't have to invalidate the flight.scala. That file hadn't changed, and it didn't depend on any of the signatures of the global discount. So that compiled class could just be used as is. Again, that's a functionality we get for free by integrating with Zinc. And in fact, this time, because we split the code up across multiple source files and multiple modules, the build was actually even faster. The build now is under 5 seconds. So hopefully you can see from that that with the build tool that we've developed, we're really able to keep developers productive. 5 seconds to build this code when you're making small changes is something that we consider to be below that threshold where developers will get bored of staring at their screen and switch away to do something else. Keeping that kind of 5 seconds or ideally lower means that developers can make small changes quickly. They can compile those changes, and then they can test their code to make sure the changes do what they want and continue iterating around that cycle until they finally develop the applications that they want to develop using the code they want to write.
Thanks, Andrew. Thanks, everybody who presented, and thank you all for listening to our talk. We hope that the sections of the talk about volunteering were interesting to you and motivational. We are really pleased about the fact that we were able to help so many students, but also how the volunteering has such a really positive impact on our own staff, and particularly the junior people, to remind them just how technically capable they are. And you know, the fact that we were also able to establish a recruitment pipeline because of this volunteering was a real surprise to us, and was, you know, far beyond anything we expected when we engaged with the volunteering initially. So, you know, as people who work in the tech industry, you know, we enjoy a great deal of privileges as a result of that, and we know that a lot of you who are listening are probably in the same position, and we want to encourage you to use that privilege to help other people, and also to point out that when you do that, you know, unexpected and great things can happen. So, you know, the other thing that we want to do today is to announce that the technical platform that you saw, which we feel has lots of exciting features, is deeply embedded with Scala. We will be open sourcing that platform. We'll open source it under the Apache 2 license, and we're going to add to the current Morgan Stanley GitHub. You know, Morgan Stanley already has a long history of open sourcing software. As you heard in the talk, part of the componentry that's used for the build infrastructure is already an open source component that Morgan Stanley open sourced some years ago. We're going to do a full open sourcing. We're going to open source the compute platform, the data platform. We're going to open source the distribution platform, the SDLC tools, the build infrastructure that you saw. We're going to open source everything. It's not all going to happen at once because it's a lot of code, but in the next few weeks, it will start to materialize under the Apache 2 license on the Morgan Stanley GitHub. Why are we doing it? What's our motivation? Our key motivation is recruitment. We hope that when people see what we're working on, if they're interested in that, they'll come and talk to us, and we'll be able to find great engineers to take the project forward. And by showing what we have, we hope that we'll get that kind of engagement. We also hope that by showing that project and the componentry and the ideas that we have inside it, that there'll be people inside of the Scala community who can critique those ideas, improve on those ideas, give us new ideas. So we also hope for that benefit too. But building on our experience from the volunteering, we also expect something to happen that is unexpected. We expect something that we haven't thought of yet to happen as a result of the open sourcing. And I'm sure that will be something positive and interesting, but we don't know what it is yet. But we are looking forward to it. So please take a look at our project, and thank you again for listening. I'm going to leave you with some links and slides, links to the volunteer organizations that we mentioned in our presentation, and link to our open sourcing page.
Hi, thank you all for being here and for the wonderful talk. We would like to do some live Q&A now, and let's get started. The first question is, are you familiar with Scala Bridge, a Scala volunteer project that sounds somewhat similar to your impact program? Scala Bridge London is an active chapter. Perhaps you can cooperate.
So I think I can take that question. Yes, we are absolutely familiar with the Scala Bridge program, which we all believe is super awesome. There are some key differences though. So the impact program is tackling education at the school level, while the Scala Bridge is tackling professionals, people that already are considering computer science as a career. They are sometimes they might be still studying, but they're definitely not undergraduate students. So that's the first key difference. This program tackles people that are underage, while I believe the Scala Bridge doesn't do that. That said, we do absolutely love the Scala Bridge program. We have collaborated with them before in the past, and it's something that we look forward to do in the future. The final goal is the same, right? We want people from underrepresented groups to start coding, and if that coding is written in Scala, we're even happier. So that is definitely interesting for us. It's definitely something that we have done in the past, and we are going to consider collaborating again in the future. Of course, COVID makes things a lot more complex. We'll definitely consider reaching out to the amazing Scala Bridge coordinators and get in touch with them. So thanks for the great suggestion.
Great, thank you. Our next question is, how can the annotations enforce referential transparency?
I'll take that one. The answer is they don't, for the most part. We trust developers to do the right thing and write code which will execute properly under this execution model. And it works very well, both because the program doesn't work if you don't do it correctly, but also because it's fairly easy for people to write referentially transparent code as long as they understand the strictures of it. And we have annotations which mark methods, which definitely should not be called inside nodes, and we use those for certain particularly dangerous methods and definitely referentially opaque methods. But for the most part, they don't.
Yeah, it's a really great question, because at the start of the project, we were super worried about people building functions that weren't referentially transparent. And so we did divide tools and stuff that we would build to like protect ourselves, but it just never has been a really significant problem, because if you think about it, most functions are referentially transparent. So in the end, it hasn't materialized as a problem. We do go into this actually quite a bit in one of our other talks. So if you it's on the Scala Exchange site if you want to look it up. But yeah, it's a totally, we were totally worried about it, but in practice it hasn't caused any significant problems.
Well, thank you both. Our next question: how do you handle effects like getting current time, generating random numbers, etc., in your graph calculations?
Yeah, I can take this one. I think this was from Joseph. It's a really great question. Again, we talked about this in our second talk at Scala Days. We have a kind of controlled way of mutating the immutable, essentially, and applying change. But for the types of non-referentially transparent functions that you're talking about, we leave it up to the developer, like Harrison said, to ensure that the code that they're annotating as at node is referentially transparent. But remember that the platform does more than just caching, where you would be concerned with non-referentially transparent functions. We can still run functions asynchronously, even if there is non-referentially transparent code there. But our current talk is online. Our talk on this is online. If you're interested in that, I recommend that talk.
Thank you. Maybe if you have a link, you'll be able to share it with us.
Yeah, I can send it around.
Great. Our next question is, what is the cost difference between outputting signatures only versus full compilation?
So for the most part, we don't actually, we never output signatures only. We run the compilation through to the end in the hopes that people will need it. But I don't have the statistics right off the top of my head, but it is, with the way that our platform works, is about half and half between the pre-signatures and the post-signatures phase. So we, depending on the amount of type magic and implicits that you use, we can usually cut around at least half of the compilation time due to the pipelining feature.
Great, thank you. Next question: does everyone have to use Windows Plus IntelliJ?
So I'll take this one. To some degree, so we're not that closely bound to Windows. All of our CI plant is working on Linux, and we have a significant amount of work that needs to be done on Linux, working with our shared calculation grids, for example. So it works to run IntelliJ in Linux with setup there to have the GUI. Also, when we compile using our build tool, in IntelliJ, it's also creating artifacts that are usable from command line compilation. So there's like a pretty smooth user experience there that's meant to keep it so it's not closely tied to how you're working, that you still end up with the same artifacts. With regards to the IntelliJ part, we are using IntelliJ IDE plugins quite heavily for a good user experience. So for example, with our annotations, we have a presentation compiler that is displayed through the IDE plugin. We have some enhanced warnings, this kind of thing. It should be possible if we needed to do those for other IDEs, but right now we've kept our focus specifically on IntelliJ. So that is required for our developers right now.
Thank you. Our next question. So based on this framework, you have sort of 2 tiers of developers, tooling developers and business rule developers. What is the split percentage-wise between the 2 groups?
I can answer that. The first thing to say is that we have a large monorepo, and all of the code for both the business application and for this framework is in the same monorepo. So that means that like the people that you see in front of you, we're all responsible for the framework. So if we have problems or we want to make changes, we can actually go and modify the business code if that's the best way to make the change. So for example, we realized sort of a while ago that the way that we have the interface for people writing data, it was suboptimal. So we changed that, but then we were able to go into all the business code and change all the uses of it so that everyone picked up the new version. And that's one of the really great things is to have a large monorepo so you can make those changes on both sides. So you know, although there is definitely a division in the code between the 2 things, that there is the possibility that you can work across them to affect change. But you know, nonetheless, people are assigned to one side or the other. I think the ratio is about 4:1 to developers of the business logic being the 4 and developers of the tooling being the 1. But you know, there are kind of other factors in that, which is that we are currently investing in the platform, and that investment we expect to increase the 4. So it's difficult to be precise unless you look back over like a long period of time.
Thank you. We do have a couple questions left. One of them is, how far along is the Scala 3 journey?
I can take that one. The short answer is that pretty far. The reality is that this framework is macro-based, and it's also, we have a lot of compiler plugins. And as some of you might know, Scala 3 drastically changed, or shall we say, improved the ecosystem. So that will require a lot of code rewriting on our side. We will get to it for sure, but it's probably going to take us some time. We have a lot of compiler plugins and macros that our framework is based on that is going to need some love, and we need time to dedicate the resources to that. So not yet, but we hope to get there in the future, hopefully not too far away.
Our final question. Why do you have to have such big code base? Why don't you have multiple smaller projects, binary dependencies?
So, I mean, James touched on this recently, and the benefits of the monorepo are something which we gain quite a bit from, which is the ability to make changes which could break or require downstream changes, and make that the responsibility of the platform developer making the change, rather than having to coordinate the release of that feature or backwards compatibility breaking change among however many other projects there might be depending on it. Because I mean, if we broke the platform, if we broke the user side of this into a bunch of related applications, there would probably be tens of projects that we have to keep tabs on the entire time. So the monorepo definitely makes it easier on us as platform developers.
Well, thank you for that. I believe that is our last question we have time for live. So I'd like to thank each of you for being here with us today, and thank you very much for presenting your talk. Hope you enjoy the rest of your day, and see you around.
Thanks.
Thank you.